Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode we're going to take a look at cooling the computer. So let's dive right into it. First you have to understand why there is a need. Basically it's because of physics. There is a law and it's a physical law, you can't break it. Is that energy cannot be created nor destroyed. Basically what that means is, let's say you put 100 watts of electricity in your computer, it's becoming 100 watts of heat that is coming out of it on the other end. So because there is no motion, nothing is moving, as in like your CPU does not move from one place to another, or even the hard disk platter that are moving, that is moving in the same sealed location. So overall it gets hot, and it gets hot directly proportional to the amount of electricity it is consuming. So let's say you have a computer that consumes, let's say a low power PC that consumes 60 watt of heat. You have a PC that is like, Threadripper, it consumes 250 watt. You have 250 watt of heating element basically. So for that reason, every component PC that consumes electricity gives out that amount of heat. So just to make sure this is the source of heat, is the electricity that is being directly used, so we have to make sure we remove it. Why do you want to remove it? First, equipment safety. You don't want your ICs to burn out and things like that, and there are many ICs in your motherboard, processor, in your graphics card. So it's not just like one thing has to be cool. Like you can't be in a scenario where, okay, you cooled your CPU but your RAM got over fried. So you have to make sure that overall the system is cool, because every IC is susceptible to it. So, and not to mention, equipment safety is very crucial. Like Xbox is famous for this red ring of death, and many people solved this by basically roasting it, and that was done because the heat sink that they applied into it was not adequate. So you can see that in the next generation of Xbox they have like gigantic heat sink because they learned from it, and they roasted it because the motherboard bent, so they had to heat it up again to bend it again, so it starts to make contact with the heat sink. So suffice to say, thermal management is a very crucial aspect of it. Then what do we use it? That's your problem. You have heat. How do we solve it? First, we use heat sinks plus heat pipes. Then we have something like this, AIO, all-in-one cooling solutions. Basically liquid system, that is everything is sold to you as a package, where you have radiator, pump, cooling block, and everything fluid, everything is done in it, and we use fan to do the final heat dissipation. So the heat sink, you see, all it does is take the heat from the hotspot, as in the processor or the GPU, and then puts it in a larger spot. How the heat is removed, that's based on the fans. So if you have a large heat sink but very little amount of fan or no fan, you may not get adequate cooling. So we come to the issues, that what are the issues that we have to face. This is very crucial nowadays, simply because of the trend to make very high end processors, where there are processors that can consume upwards of 300 watts of power, AMD Threadripper specifically, and not to mention the trend to put i9 in laptop, which without adequate cooling is flat out useless, because it thermal throttles so badly that it performs more or less like an i7. And the reason for that, the core reason, is that what's called slow thermal conductivity. Basically this thermal graph should help you understand this very accurately. Is that if you have a heat sink and you have a heat source, it does not travel to at every corner of the system instantaneously. It takes time, and the problem is, as long as it's taking time, it's getting hotter and hotter and hotter, provided the heat load is constant. So let's say you have a 50 watt processor, it's giving out that 50 watt constantly, okay, no problem with that. But point is, this place will become 50 degrees Celsius, supposed to be, but this place will remain as cool as ambient temperature, because this is not sinking the heat. It takes time. The material, no matter what material you use, either you use copper or aluminum, has a time. It cannot just go to like full conductivity in 0 to 100% in 1 second. It takes time. Now problem is that it inherently ends up in a scenario where this spot overheats. Even though you have so much cooling area, this spot overheats. To solve that, we use what's called heat pipe, as you can see in things like this. Now you might see AMD processor which is like one small block, but why it has heat pipes? For simple reason, they'll run the heat prime from here to edges. Basically because heat pipe have fluid that is moving up and down, it's conducting heat much more faster than the passive conduction of heat. So this is crucial factor. That's why heat pipe, everybody is going on about heat pipes, like it has 6 heat pipes, it has fat heat pipes, it has like slim heat pipes. That's the reason. If you don't use fluid, And if any fluid, it could be any fluid that is specific for that purpose, if you rely on metal directly, will it work? Yes, absolutely. If you have low heat load, that's more than enough. But if you have high heat load, like a lot of heat coming from a small point, as in like AMD Threadripper is giving off 300 watts of heat, you need to dissipate that heat quickly, otherwise it will burn itself out. Now, don't worry, it won't actually burn itself out. Modern processors have a lot of fail-safe, they will simply cut the power. So, and this heat pipe is becoming so efficient that we also use in your laptop. So your radiator could be here, and the heat pipe is conducting the heat from the CPU, from the GPU to your radiator. Now this is how we do air cooling. So in air cooling, you have to understand it's very cheap and it's very effective. I told you, like if you have a small heat load, you don't even need fans. Like let's say very small load, as in like 20 Pentium 4, Pentium 3 kind of system where it's very low thermal requirement. You just put a heat sink, you don't have to worry about anything. And earlier heat sinks did not used to come with what we call heat pipes, and as you can see in this one, this was the common heat sink we used to use, does not have any heat pipe. So the core of this system will get hot, but the outer ring will not be cooling because of that reason. So in recent years there have been a lot of cheap effective heat sinks that have been flooded the market, and you can cheap out on this, provided if they are not selling overselling it. Basically if they sell you something that it's a TDP of 300 watt and it barely has capacity of 50 watts, then you are screwed. But if they say it's 100 watt and you have to choose between Cooler Master or Deep Cool gives you cheap one, buy Deep Cool, you won't regret it. And fan, of course, it's up to you, but fan generally don't break down, even cheap Chinese one. So there have been a lot of improvement, and the noise complaint that people used to have from things like this is gone, because basically we started to use bigger fan. 120 millimeter fan is the big standard right now, and you can go a bit higher than that, what's called 140 millimeter, but it does not give you that night and day difference between small fan to 120 millimeter fan. So that's a day and night difference. The noise level would be like very little, and if you go from 120 to 140, the gap is not that much. So this is about air cooling. So at this point, you can buy a Cooler Master and forget about it. You should buy these things, not because of the money reason. Simply if you are a PC enthusiast and if you want to upgrade your PC, you can buy these things, and these are future proof. And if they are buying them from a branded company, they generally sell you adapter kits. Let's say there is a new processor, they will sell you just adapter kit just to adapt it. So for that reason, this can be like your cabinet. It can be working for years and years and years and decades and decades. Then we come to the liquid cooling. Now what you have to understand, this and liquid cooling has no core difference. The only difference is that liquid was in the heat pipe. Here the liquid is either the water or oil that they are moving through the radiator. It's basically the same thing, only heat pipe used to be like very strong, very rigid, like they are structural component of laptops, some laptops. So suffice to say, this uses pipe, and instead of having heat pipes, they are using the water that is running in them to carry the heat around. The core benefit of it, the first benefit you will see is it's called better exhaust. Basically your heat is, let's say this is your processor, it's heating up. If you have an air cooler, it's coming out of like that and it's just heating everything around it. Now if you have liquid cooler, because the radiator is designed in such a way that it has very slim factor, is the air is just directly goes out. It's exhausting the heat directly. So basically this whole area is not getting heating up. And this example is even better. As you can see, like this whole area is very cool because the heat from the CPU is not coming off. It's coming off directly there and directly being exhausted. So better exhaust is a really core selling factor of liquid cooling. And you have to understand, many of that big beefy air coolers, they put a lot of stress on your motherboard. Basically, as you can realize, we generally have motherboard not lying down like this. So it's big heavy block like this coming out of it. It's putting a lot of stress. Now it's not an issue, but you have to be mindful. It might become a headache if you have a really big powerful CPU. So liquid cooling starts to make more sense in that sort of scenario. But do be mindful, not every cabinet supports this. So do check your manufacturer. Then we come to the new king in town, oil cooling. Now oil cooling have been done by enthusiasts, hackers, overclockers for decades, but it never caught on simply because it did not provide any unique or any actual benefit. However, nowadays it's making a comeback, not for consumer market, but for server industry, as you can see in this one. And Intel, just I will link the description below. Basically, link would be in the description. And Intel run basically a test with this sort of system where they had 42U, basically the unit 42 unit system, where they had two 42 units, one cooled by air, one cooled by oil. Now oil has many advantage. First, it's fully submerged, so there is no humidity that is touching your components. Humidity do cause your components to fail prematurely because of corrosions. Benefit number one. Second, because it's fully submerged, there is no hot spot. There is no spot where, like, let's say your CPU got too hot and it started to bend the motherboard, like in PlayStation, and it does happen in server. It's not too often, they generally design it well, but things like that happen. Here, no worry about that. Second, you have to understand packing efficiency is very crucial. The land area that you have to buy for your server, it's very crucial. Like, you want to take as much money out of it as quickly as possible. For that reason, you want to put as much server as you can in the square hectare that you bought. So for that reason, packing efficiency of this is also higher. Not because you can't pack air cooling as close to each other as like this. It's just simply in air cooler it will get roasted by itself. The air does not conduct heat away quickly enough. And low noise, now this is crucial. There are documentaries about, like, people going behind the scene of Google, and you will see them wearing ear protections. It's loud, idiotically loud. The fan, the small form factor fans, they are ludicrously loud, ludicrously inefficient, ludicrously expensive. For this reason, I expect to see this slowly will catch on. It won't catch on like, today and tomorrow every next gen servers are built like this, but it will catch on sooner or later, because now Intel has jumped into it. So since they make the largest amount of processor, and Samsung, so you have to realize, like, there is a very good trend about it. And you can do it in your home also, but it does not serve that much function. So the very fact that this allows you to have quiet, basically you don't need hearing protection, have to have long components sealed off from environment, basically no humidity will damage it. Awesome. So all things considered, oil cooling will become the next de facto, and specifically because we are going to use a lot of artificial intelligence and things like that, we need to pack them in small places. You can't have artificial intelligence that has to communicate longer distance. Not because, like, there is a issue that we can't do that, is simply because of the lag. And you might be like, okay, server to server, the lag is not there. Yes, it's there. If you are creating a neural network, the nodes from each network is acting in a virtual world. Now that virtual world is limited by the connection speed of these things. And if you have, like, this one here, another 5 meters away, there is a 5-meter time lag. Now it's minuscule. However, imagine if you have hundreds of them. Now you're realizing communication from one point to another point could have as high as, like, 0.1 millisecond or 0.7 millisecond, or sometimes one whole millisecond. So packing efficiency is very crucial for artificial intelligence, high-end artificial intelligence. And Google is also investing in a lot of money into making sure they can make oil cooled servers. So this was my presentation on PC cooling solutions. I hope you liked it or learned from it. In that case, please like. If you didn't, don't worry about it, dislike it. Leave a comment. And what would you want to see in the next episode of Computer Wednesday? And subscribe. Press the bell icon, as I make video every day. And as always, thanks for watching.